9.5, or as I would like to say, it is 9.2 part 2. Everything that we do in 9.5 is just like 9.2. You can see a lot of those same formulas. The only difference from 9.2 to 9.5, instead of being on the unit circle where the radius is 1 of the circle, notice now we can let the radius be whatever we want it to be. Okay? So take all those formulas that we saw in 9.2 where it said sine is equal to y, cosine is equal to x, and now we just take all those and we slap them over r, okay? Where r is no longer 1 because now we're dealing with a circle that is bigger than the unit circle. So 9.2 was all about the unit circle where r was 1. So like x squared plus y squared equaled 1, okay? Or another formula of that is r squared equals x squared plus y squared. Again, this is just Pythagorean theorem, but this is also the formula for a circle that is centered at the origin. So all this is still the same information as 9.2. The only difference is that the radius of the circle is not 1 anymore, as in the unit circle. Now the radius can be whatever it wants, but all the formulas still stay the same. Okay? So y over r is still sine. Sine is still about y. Cosine is still about x. It's just over r. Okay? Tangent, this is the same exact formula. Y over x. And then over here, you got the other three. Cosecant is the reciprocal of y over r, so you get r over y. Secant is the reciprocal of cosine, so you get r over x. And cotangent is the reciprocal of tangent, so you get x over y. Okay, again, this is everything that we're doing in here is just like 9.2. The only small teeny tiny difference is instead of being the unit circle where the radius is 1, now the radius can be whatever it wants. The circles can be larger, they can be smaller. Okay, we also get some other pieces. When we were in 9.2, I showed you the Pythagorean identity with sines and cosines, but here are two other Pythagorean identities. Please also know that you can rearrange these any way you want, so that another possibility could be that 1 equals secant squared theta minus tangent squared theta, because we can easily subtract this over to the other side. So secant squared minus tangent squared equals 1. And you could do all sorts of other things. You could say that that tangent squared equals secant squared minus 1 by moving the 1 over to the other side. So any combinations of manipulations here are also true. Okay? So these are going to be the basic ideas we use in 9.5. Okay? Along with these as well. So as you can see with our first problem, I'm going to give you this point. This is x and y. I want you to find the 6 trig functions. Also, it's going to ask you to graph in standard form. Now, you know how to graph in standard form, okay? But I'm going to go ahead and say, yeah, I want you to try this on your own. This isn't anything new, okay? So you can do this. This graph, it probably needs to be a little bit better. Let me move it down, because in our graph here, this is a 10 by 10 by 10, negative 10 by negative 10. So obviously our point goes out to 12. So we need to kind of stretch this a little bit and maybe make so there's mark 11 and there's mark 12. And then coming over here, here's mark, oops, grab this guy. Yeah, that's a little better. So over here is mark 11 and 12. Over here is mark 11 and 12. And then hide this little guy down here. Here's mark 11 and 12. So you probably need that information right there. Let's make it a part of all that graph right there. So there we go. So now that's all one. Okay? So now, go ahead, pause the video, and do this. I'll give you a hint. You need to find R. and we have a formula for helping you find r. Square root of x squared plus y squared, okay? And you need to keep r exact, no decimals. And go. All right, so let's come in here. And the first thing we need to do is we need to find r, okay? So we have r equals the square root of x squared plus y squared, okay? So you need to plug into this little formula right there. All right. So I'm going to grab this, move it over a little bit, give me a little bit of room to work over here. So we got r equals square root of -5 squared plus 12 squared. So r is equal to -5 squared is 25 plus 144. So that will give us r equals the square root of 169, which is equal to 13. And this r always has to be positive. The radius has to be positive, no matter what, because a radius is a positive distance. So you don't have to worry about any pluses or minuses out here, okay? That radius has to be positive. All right, so now that you know what the r is, and up here, hopefully you know that this is the x, this is the y, all you do is just make your fractions and always reduce them. So sine is y over r. So that would be 12 over 13. There's your sine value. Cosine is x over r. That will be -5 over 13. And again, these aren't reducing, so that's the answer. Just like what we did in 9-2, except again, like I said, the only difference is our radius is not 1. All right. Tangent is y over x. So that would be 12 over -5. And if you want, you could take the negative and push it out front and say it's -12 over 5. It's all fine. But it's fine to keep the negative in the denominator. So there's the big 3. All we do for the other guys is flip them. So this is the reciprocal of sine. So that's 13 over 12. This guy is the reciprocal of cosine. So that's 13 over -5. Cotangent is the reciprocal of tangent. So that's -5 over 12. There you go. We probably should have answered this question first, but it wants to know what is the standard form or standard position. Remember, standard position, it's from the origin and it comes out here. Okay. And then from there, all we're going to do is rotate to -5, +12. 1, 2, 3, 4, 5, and 12 is up here. Oops, not letting me draw. And this is the direction it rotated because we are always rotating positive thetas. Okay? So there you go. There's standard position. That's what it looks like. All right? So again, just like what we were doing in 9-2, they're having you draw standard position. So you just plot the point, keep the initial vertex, or sorry, the initial ray on the positive side, and then it rotates counterclockwise. Make sure that you find the r value because the radius is not 1. And then you just plug into those formulas. Y over r, x over r, y over x. And then these guys over here are the reciprocals. Okay? Always reduce those fractions. Just like what we did in 9-2. Like I said, this is why I call this like 9.2 part 2, because it's just like 9-2. The only difference is our radius is not 1 anymore. So go ahead, try this one. You know all this information. You know how to do this. Oops, did not mean to do that. Let's go back to undo. What I meant to do was give you the entire page. And pause the video and go. Okay. So if I come back in here, let's go ahead and draw the initial position first, or the standard position. So 1, 2, 3, 4, 5. So there's the initial side. And then the terminal side, we were at -5, 0. So 1, 2, 3, 4, 5. And there we go. Hopefully you found the R value pretty easy, because you got R equal to the square root of -5 squared plus 0 squared, which is equal to 25 plus 0, which is basically in the end equal to 5, because 25 plus 0 is 25, square root of 25 is 5. So now you just write all of your answers. Y over R, which is 0 over 5, so that answer is 0. They do not want 0 over 5, they want an answer of 0. Cosine is -5, because that's the x, over R, which gives us -1. Tangent is going to be 0 over -5, which is 0. So hopefully you notice that this is one of those quadrantal angles that we talked about in 9.2. Okay, it's quadrantal, it's along our axes. And then over here, all we do is take those reciprocals. Remember, we talked about the reciprocal of 0, because what would happen is we would end up putting the 5 over the 0. And remember that we do not like 0 in the denominator, so the reciprocals of 0 are the answer undefined. Okay? Reciprocal of -1, we've talked about, is still -1. Okay? Because all you're going to end up doing is putting 5 over a -5, and that's still -1. And then again, reciprocal of 0, undefined. Okay? There you go. Again, nothing crazy. You've already done all this information before. This is not new. Okay? All right. So again, they want you to find the exact values for these. Now here's what's cool in this. I have given you notes out here. It's called the trigonometry chart. It looks like this. Okay, this is where you're going to start using this chart. So they might give you degrees. They might give you radians. And all you have to do for this problem, I want you to start using this chart. It's kind of like your Bible, is go to that chart and look up this answer. We want to know what is sine of 0 degrees. So we go into our chart here. So here's 0 degrees. Here is sine. So the answer is 0. Okay, I want you to start using this chart to help you out. So this column is all about degrees. This column is all about the radians for that same measure. And then out here, you can see all the answers for sines, cosines, tangent, cotangent, secant, cosecant. Okay. Other things about this chart, it goes all the way down to 360, which this guy is the same thing as being 0 degrees right back up at the top. Okay. Also know that if you start right here at 0 degrees and then start working these same numbers backwards as negatives, so this is -30 degrees. This is -45 degrees, -60, and you keep going and reverse the numbers that started in this order. Come on, you. Went backwards on me. So it goes 0, 30, 45, 60, 90, 120, 135, 150. If you did that same thing down here, and you go 0, -30, -45, -60, -90, -120, -135. So you've got all the angles going backwards there too for you. So you can also write that out to the side on your chart here, and you have all the angles working their way backwards. Okay? So you got all that information right here on this chart. This chart you're going to use a lot. So make sure you definitely have this handy. Okay? So we already know that if we go back to our chart and look this up, 0 degrees, sine, the answer is 0. Excuse me. Oh, bless me. So I've got a couple more here. Try these. Go ahead and pause the video and see what you get. I'll give you a hint. Think coterminal. And go. All right. So in here, for this guy, this 630 degrees. Again, it's not on our chart, but we can take that 630 and we can make it coterminal. We can find that least positive coterminal value here. So all we're going to do is take the 630 and we're going to keep subtracting 360 until we get between that 0 and 360. So if I go to my calculator, I take 630 minus 360, I get 270. Now that angle is between 0 and 360. So what we really want to find here is what is secant 270 degrees. This answer has the same answer as secant 630. So again, you just go to your chart. So 270, here it is. And we need secant. So that is the second to last column. So scrolling down, 270. So here it is. Here's 270. Second to last column right here is secant. So the answer is undefined. Hopefully you took my little hint and that's what you did. And again, the same thing's going to happen right here, negative 540. It's not on our chart. But I did talk to you about how to find these going the negative direction. So you could use that. Or again, just, turn this into the positive, least positive coterminal angle. Okay? So we're going to add 360 to negative 540. And that gives us negative 180. That's still not the least positive, but you could actually figure it out from there if you actually rewrote the negative angles. So if I add 360 again, what we're looking at is cotangent 180 degrees. That is the least positive coterminal angle to this. See, I said coterminal is pretty important for us. Okay, so now if we just go to our chart, coterminal is the third column from the right, and we want 180. So 180, third column from the right, there it is. That answer is also undefined. And there we go. So that's why I'm giving you this chart now, so you can start using it to its full advantage. Okay? So think about that. Have that chart ready to help you out on some of these. Okay? Same thing. No, it couldn't have. Never mind. Ignore what I was about to say. All right. So now they want you to take this cosine theta, which is equal to negative 2 over 7, and tell me what secant theta is. Okay? So they want you to take this cosine negative 2/7 and tell us what secant theta is. So let's talk about this. So a couple things. When you look at these, make sure you understand how cosine is made. It is made up of x over r. And I've told you some very important things about r. R has to be positive no matter what. The radius has to be positive. So this negative that is out front will not go with the 7. That negative will actually go with the 2, okay? Because that's the x value. So in here, we know that we have a negative 2, comma, something, where the r value is equal to 7, okay? So if you wanted to, you can actually figure out the y value. You have that r squared plus y squared equal to x squared, or r squared plus equals x squared plus y squared. Okay, you can solve and figure out what y is. The one problem is you're not going to know if y is supposed to be positive, or if it's supposed to be negative. Okay, you need a little bit more information other than that, but you could actually figure out what y is, because again, like I said, we have a formula: r squared equals x squared plus y squared. That's why I gave you that other formula at the very beginning in the parentheses there. Okay, I don't really want to use this one. I would rather use this guy that's right there. All right, so again, if I go back to this one, let me jump down to it. If I do some plugging in, so my r is 7 squared plus, or sorry, not plus, equals my x, which is negative 2 squared, plus my y, which I don't know, so we'll just call that y squared. Okay? And so this gives me 49 equal to 4 plus y squared. So y squared is equal to 45. And then you take the square root of that, and you end up with plus or minus the square root of 45. Now, don't forget, you would need to reduce this if it can, and it actually does reduce. And if you reduce this thing properly, you're going to end up with plus or minus 3 square roots of 5. If you need to know how to reduce that, please come see me in some Zoom sessions. We talk about reducing radicals, but this is really what the y value is. And again, you got to leave the plus or minus in there because we don't know if the y value is supposed to be positive or negative, because they didn't tell us any information about that. Okay, so usually if they tell you some information, it might tell you about some of the trig functions, or it might say what quadrant you're supposed to be in, things like that. So right now we don't know what the y is. The y could be a positive 3 square roots of 5. The y could be a negative 3 square roots of 5. Now your question, usually what you're going to be like, well, Mr. Armstrong, how do I answer this question? Well, think about what they're asking you here. Okay, they want to know what secant is. Remember, the formula for secant is r over x. So the y value doesn't even really matter. We just need to take the cosine and actually flip it. So that's a negative 7 over 2. Now you're probably like, Mr. Armstrong, why did you even talk about the y value? Because I want you to know sometimes you might have to solve for this guy to figure these out. Okay? You might actually have to solve for that. So that's important to know. Try this one. Okay, so if you're looking at this, again, you need to remember that this is actually a fraction. This guy is over the number 1. How is cosecant made? It is made by r over y. So you now know that you've got a blank, your y value is 1, and your cosecant, or your r value, is the square root of 15. Okay, again, you could solve for x. There's nothing wrong with that. You can actually solve for x. Okay, but they want you to find this information. Again, if we think about what's going on here, okay, sine is made up of y over r. So I don't technically need to solve for x here. Okay, but you could, using the same information that we did right over here. Okay, you could solve for x using that same formula. So let's plug in what we know. We know that y is 1, and then the r is the square root of 15. Again, just like what we've talked about before, you cannot have radicals in the denominator. You need to rationalize. And in order to rationalize, you just multiply by what is in the denominator. Square root of 15 over the square root of 15. So your true answer you end up with on top is the square root of 15. And on bottom, remember, when you multiply two radicals that are the same, the radical just disappears. So that is the sign value that they are after. Square root of 15 over 15. Okay? All right. Not too bad. Pretty straightforward. Okay? So let's take a look at what's next. So here, again, you've seen these. So you need to remember back from 9.2, the A, S, T, C. All students take calculus. Okay? All students take calculus. And remember that told you the quadrants where trig functions were positive. A for all, S as in students, this is for sine and its reciprocal, cosecant. T, take, which is tangent and its reciprocal, cotangent. And then last but not least, C for calculus or chemistry, which is cosine and its reciprocal, secant. Okay? So, remember I said you approach this like you're dealing with two problems here. First things first, let's talk about sine. When is sine greater than 0? In other words, that means positive. When is sine positive? Well, it's positive in quadrant 1, and it's positive in quadrant 2. Quadrant 1 and quadrant 2. Then you're going to look at cosecant. When is cosecant? According to this, they want it to be positive. Okay? Well, cosecant is positive in quadrant 1, and cosecant is positive in quadrant 2. So the answer to this problem is what both the quadrants, both of these share. Sometimes it's one quadrant, sometimes it's two quadrants, sometimes it's none. Okay? So the most you will have for an answer in this is 2. The smallest answer in this is going to be none. Okay? 0 quadrants, 1 quadrant, or 2 quadrants. Well, according to this, what they both share are quadrants 1 and quadrant 2, and that's the answer. Quadrants 1 and quadrant 2. There you go. Just like what we did in 9.2. Okay? They're asking the same kind of questions again. And I believe I've got one more question left. I think this is the last one. Yep. Here we go. So now they want you to use your calculator, okay? And they actually want you to figure out what theta is, okay? So they want you to figure out what theta is. So this is kind of a precursor to what we talk about. It's called inverse trig, okay? So we want to figure out what is cotangent of 0.125, okay? And we want to figure out what is sine when it's negative 1.006. All right. So let's bring up our calculator. Okay. Let me shrink some things down. And this is the last piece of 9.5. So calculator, there you are. Okay. So it's bringing that up for us. So what you guys are dealing with in this is inverse trig, okay? And on our calculator, our inverse trigs are these little guys in blue right up in here. Sine to the -1, cosine to the -1, tangent to the -1. Those are our inverse trig functions. What inverse trig does is it helps you find the thetas, or in other words, it's helping you find the angles. And they're going to want these angles, if I remember correctly, in degrees. Okay? Or actually, let me double check that. Let's make sure that we put them in the correct, excuse me, mode. So they want this information given as actually, I take that back. You're not going to be using inverse trig yet. What they want to know is is this possible or impossible? Okay? So can we figure this information out? So just kidding. No inverse trig yet. But I just showed you where they were. It's right up here. We're going to get to inverse trig, I believe, in the next section, 9.6. We'll do a little bit of inverse trig. Let me make sure on that. I'm pretty sure we do. Then I'm pretty sure we don't. Joking. No inverse trig there. Okay? Well, maybe. Yeah, it looks like there's a little bit of inverse trig once we get to 9.6. So we'll worry about that when we get there, okay? So for right now, they just want to know, is it possible or impossible? Okay? And this is really easy to deal with. So right under here are the ranges for the inverse, okay? As long as when you're looking for sine and cosine, if the value they're giving you is between -1 and 0, remember brackets mean that we include the -1, you can find the inverse. It is possible. So if we are outside this interval, we cannot find the inverse for sine and cosine. Cosecant and secant, as long as the value you're looking for is between -infinity and -1, or 1 and infinity, you can find the inverse to it. It is possible. That means if you're between these two in here, if you're between -1 and 1, you cannot find it. Cotangent, as long as you got any number, you can find the inverse of tangent and cotangent. Okay? So this means any number will work. So if we look at this right here, based off of this information, cotangent, we're looking at the number 0.125. So is 0.125 in this interval? Absolutely. Any number is in this interval. So is this possible or impossible? And the answer is possible. And that's all they want. Okay? Go ahead, pause the video real quick. Think about this one right here. Can I find the inverse to this number right here using sine? Go ahead, think about it, pause, go. Okay. So in here, -1.006. Is -1.006 inside here? No, it is not. -1 is a little bit lower than 0.006 is a little bit lower than this guy. So this number is outside this range. Okay? So that means this is impossible. So there you go. That's what you're going to be looking at in section 9.5. See? Nothing crazy. You guys got this. And I will see you next time. Peace out.